A group of students were playing soccer. With the game tied at 1-1, Titus needs to make the penalty kick for them to win the game. Before the penalty kick,
Titus, remember a lesson in science about projectile motion? If you notice, a ball travels in a curved path. This happens when an object, called the projectile, moves in two dimensions, having both horizontal and vertical components acted upon by gravity.
Titus knows that the distance from the penalty kick to the corner of the goalpost is more or less 11.5 meters, and the goalpost is 2.44 meters. He also knows that his average kick is around 14 meters per second. With that in mind, Titus needs to be accurate on what angle should he kick the ball.
In order for Titus to determine the perfect kick, first, he must find the motion in both vertical and horizontal direction.
In kinematics equation, we know that in vertical direction, y is equals to y initial plus v initial in y direction times time minus 1/2 gravitational acceleration times time squared, which is also equal to y is equals to y initial plus v initial times sine theta times time minus 1/2 gravitational acceleration times time squared. Plugging in the values, we now have 2.44 equals 0 plus 14 times sine theta times time minus 4.9 times sine squared.
In kinematics equation, we also know that in horizontal direction, x is equal to v initial in x direction times time. Plugging in the values, we now have 11.5 is equal to 14 cosine theta times time. Isolating the time, we have time is equal to 11.5 divided by 14 cosine theta.
We now have two equations, two unknowns. Let's plug in the value of time in the first equation, and we can now solve for the angle since it is the only unknown variable. Solving for the theta, it will be equal to 31.2 degrees of approximately 31 degrees. Titus needs the angle of release to be equal to 31 degrees.
Can you think of some other ways how the concept of projectile motion is being applied in real-life situations? Let me know.